Hello and welcome to the Materialise 3D Printing Trends Roundtable. Today, companies adopt 3D printing for large-scale production across multiple production sites. Historically, a lot of 3D printing production happened isolated, separated from the conventional manufacturing process. But as the walls between these two manufacturing environments disappear, these two ecosystems now start to connect. Such a unified, increasingly digital production environment requires a common resource, a common language, and that is data. So moving forward, we believe the role of data in AM will become increasingly important in many ways. To talk about this, the role and the importance of data in AM, I'm joined by some of my finest Materialise colleagues. Welcome everyone. Let's start by talking about the role and relevance of data in AM. But question for you, is the role of data in AM more important than the role of data in, let's say, traditional manufacturing?
Well, if you think about Industry 4.0 or you think about smart manufacturing, that all started in traditional manufacturing. And data is important in traditional manufacturing, but what we are doing in additive manufacturing is even more complicated than traditional manufacturing, because what we are doing in AM is creating material at the moment that you are creating the products. So if data is so important in traditional manufacturing, how more important can data be in additive manufacturing? So yes, I think, Christophe, the data is very important in AM.
Yeah. So it's important, but is it also the solution to everything? Is it a magical solution for AM to solve all of our problems?
Well, I think as an industry we claim that AM is a smart manufacturing technology. So I would say that the base to be smart is to collect data. So data is important, but is that the solution? I think what we need to do something with the data. And what we need to do with the data is to analyze the data, to make actionable conclusions out of it. And actionable conclusions means that with the results of the data, we can take actions, we can improve the process, we can do the process better and make better products.
Mm-hmm. Tim, if you look at the production sites, the industrial production sites, how do you think data can change the nature of these production sites?
Well, I think data will be incredibly important in all of the different segments that additive manufacturing plays a role. I think having a rich history of data will really allow people to reduce the scrap rates, to look for failures during the printing, but even predict failures before you start printing, which is even more important. I also think that data will be, or is already, an incredibly important tool to further scale up your production, where things like workflow automation will be very important. And in the end, data will be crucial to make sure that we meet the quality constraints for end part manufacturing. To give you an example, one of the customers that I talked to, he said, we believe in a world where even the next generation or the next part that we print is a better version of the previous printed part. So showcasing the belief in the power of data and that this learning can even be done on the fly, that would really be a big dream. What is of course very important if you want to create such a system, that software platforms are capable of connecting to all of the systems in the production environment, but even beyond, because it's really by combining a lot of data that you can exponentially create more opportunities. And I think there lies a very big a key role.
Okay. Peter, you work in the medical AM business. What is the importance of data in AM in the for medical applications?
Yeah, huge in general, I would say, although we should probably make distinction between two types of data. On the one hand, you have data really related to AM, like what the colleagues here talked about. And there as well, if you look at our industry, you see that more and more companies are upscaling, specifically related to personalized care that they're often delivering with additively manufactured parts. And they're ensuring quality as they're upscaling their manufacturing is something where data can play an important role. At the same time, we're also seeing that in healthcare, more complex use cases are being handled with more complex materials as well that are additively manufactured. Think about biosorbable, for example. We can create implants nowadays that will gradually be replaced by normal tissue after implantation. Controlling that time aspect is an additional process control quality that we need to ensure during manufacturing. And so it's bringing an additional need towards the additive manufacturing industry. If you look at personal data, on the other hand, that's the other dimension that's in healthcare quite specific. That's probably even more complex, and there's also a huge amount of opportunity there. I think on two levels. One, on basically making the entire workflow, like Tim also mentioned, making the workflow more efficient by automating, for example, with technologies like artificial intelligence. But also by making the devices in the end smarter. If you can incorporate more data across the chain of creating, for example, a personalized treatment for somebody, if you can incorporate that also in the development of your AM device, that's in the end going to impact the patient probably in the most important way. Obviously, related to personal data, we have the additional complexity of privacy and data security that's coming into play, which may be different from other sources of data.
In an industrial context, I think data ownership is an important thing, because if you look at what additive manufacturing can bring, it really brings that promise of a digital supply chain where you can print whatever you need, whenever you need it. That's a big promise of additive manufacturing, which means that you have distributed manufacturing where you have a lot of distributed subcontracting going on. And how you handle that data in that whole network is, of course, a very important question mark that we need to solve, so that people are confident that their data is owned by the right person, controlled by the right person, etc.
Okay. Well, I think we've established that data plays a crucial role in AM, even more so than in traditional production environments. More specifically, access to more data will allow us to better control and improve the production process. But simply capturing the data is not enough. We need to create actionable insights. So as Bart said, having data is not the solution, it is simply the start. We already touched upon the topic of privacy and ownership in data, so let's talk a little bit more about that. Peter, I know that's close to your heart. In AM production, there's many stakeholders, but who actually owns the data?
Who owns the data, Christophe? Many books have been written to try and capture the question. Many laws have been established on the books to try and regulate the issue. We don't have the time to summarize them all. Let's try and be more specific. And in order to do so, I would like to come back to what Bart said. Additive manufacturing claims to be smart. Let's try and establish a link between the data and what smart means. Who owns the data is a too abstract question. Data are carriers of information. So the question becomes, who owns the information? That's already more specific. It's still too abstract, because information is the basis to form and to create more intelligent processes and more intelligent designs. Now, if you ask a customer, not who owns your data, but who owns your intelligent processes, who owns your intelligent designs, they will also all say, I do. And if I don't own them technically, legally, at least I want to control them. So if we bring additive manufacturing to our customers as a more smart way to make products, then I think it's only normal that at least we offer them the opportunity to control the outcome of the intelligence. And in order to control the outcome of an intelligent use of AM, they have to own the information that is the basis for that intelligence. They have to own the data. Now, they can decide to share the data. They can decide to create a bigger pool of people to increase the intelligence. but that should be their decision. So by default, the customer should control the data so that he can start building knowledge on top of that. And then he should be able to decide whether he wants to share that with other people or not.
So it's not just about owning data, it's about controlling the data.
Yes, there's definitely a distinction, I would say, between owning and controlling. And from an operational perspective, what matters is the customer should control. The user of the machine should be in control of the data that he generates so that he can, on the basis thereof, build a more intelligent way of manufacturing that will distinguish him or her from the competition.
But what about medical AM? Again, Peter, who owns the data in medical AM then?
Yeah, again, we should probably make the same distinction as we made earlier. So if you talk about machine data, process data, I think I totally follow Peter's reasoning. I mean, that's probably going to be the hospitals, the medical device companies who establish an AM workflow, and we need to have control over their data to ensure quality going forward. I think if you talk about the personal data aspect of it, that's much more complicated. If there are a lot of books written about other types of data than about personal data or patient data, many, many more have been written, and I think it's still unclear at this point in time. But essentially, that's probably not, ownership there is probably not the question that we should try and answer. I mean, what are we trying to achieve? We're trying to create benefits for patients with data. Do we need ownership on that? Perhaps not always. Do we need control and access to that? Yes, that's definitely something that we need to establish. And that's today still a big challenge. Definitely if you look at an entire journey from diagnosis to treatment to follow-up, that data is very siloed at this point in time. And there are different people who control different parts of the data. In the end, if we're going to deliver the most optimal care, then finding a way to get access to that data and integrate that to create meaningful applications, that's one of the challenges that we're going to have to solve through collaboration and addressing technical, legal, maybe even ethical challenges that we may come across in actually doing that.
And also I would like to pick on that in the industrial context, because you have the fact that today in a traditional manufacturing setting, everything was centralized. And now that we're moving to distributed manufacturing, what Tim mentioned, it's very interesting because you're kind of splitting up the whole process in a digital section. And then the question is, if the end user wants to own the data, that also comes with a certain responsibility and a certain liability, something that before was provided probably by the central manufacturer. And so this is really interesting, this shift. And the question is, if you want to then have full ownership, are you also ready to bear that responsibility? And then you have everything in place to validate and to ensure the components that you will own will function. And so I think that's also a very important thing. And the whole legal framework around that is still under development. And I think that will be very interesting to see how those frameworks can enable this dream of fully distributed digital manufacturing across the globe.
So ownership, control, liability now also added?
Yeah, and I think indeed here, what Peter mentioned before, having the choice, the owner of or the manufacturer, the 3D printer in this particular case, should have the choice what to do with the data, who owns the data, and more importantly even, who controls the data. Because the example that you mentioned, Crystal, about liability, well, you can be as manufacturer, 3D printing manufacturer, you can be liable for your products. And in that case, you really want to control your own data to make sure that the product that you deliver to your customer is according to your own standards. But there are also situations where indeed your customer, as manufacturer, imposes you to comply with certain quality standards. And in that case, you will have to share, most probably, your data. Like maybe it also makes sense to share your data with the machine makers of your 3D printers, because sharing that data with your machine suppliers might help you in having more predictive maintenance on your machines or making sure that your machines are in proper condition. And I think that here it will be important as well that in the ownership of data, that anonymization is taking place so that you can, as an owner of the data, as a generator of the data, that you can with confidence share this data without, at the end of the day, disclosing your internal know-how on how you get to a certain product. What is something in the manufacturing world what most of the manufacturers try to protect, to differentiate them from their colleagues.
Mm-hmm. And that's interesting because this whole discussion on a manufacturing process level is true, but for the same level, it's also true for the designs. Imagine companies really coming up with innovative designs, which a design is interacting with the way you manufacture it. How are they going to protect their intellectual property if tomorrow this is uploaded in the cloud and everybody can download it and print it on the go with whomever they want? How are they going to be, let's say, having at least recognition, let's say, for the intellectual work they have done there? I think that is a very interesting shift as well. Before they were owning the files, the design engineering, they manufactured it, they had the stock, and they were controlling it fully. Tomorrow, if they're not responsible anymore for manufacturing and bringing the product to their clients, how are they going to play a role in this entire digital chain?
And distributed manufacturing and cloud-based data manufacturing is only going to make that more difficult, I would imagine.
But also to follow up on what Crystal said, if I'm going to be liable for certain changes that I've made, then I want to have a data store that allows me to clearly show which changes I have made and what was the initial design that came in. And I also want to have a data store that allows me to check whether the few changes that I have made effectively improve or create risks. So it's not only a question of who owns or controls the data in the sense they're mine, but also allow me to organize my data in such a way that I know what's going on, so that if ever there's a problem, I can explain to what extent I am involved, but even more importantly, that I can learn lessons from the past and continuously, like you said, Tim, continuously improve my data. So it's not just they're mine, but allow me, give me solutions so that I can really manage and understand my data.
And if you apply that to medical, I mean, that's even going to be a requirement to ensure the quality of your devices in the end. If we're going to manufacture things in a distributed way, where we're going to give certain part of the control away, then we need to make sure that we at least capture the data on that to provide the proper end quality in the end.
Okay. Well, I think, Peter, you raise an interesting point there. Right? The question is not just who owns the data, but also who controls the data. And coming back to these actionable insights, in order to create these actionable insights, you need to be able to control the data. Controlling the data, doing something meaningful with it, requires human intervention. In fact, skilled human intervention. So while we say that data will allow us to optimize the process and increase automation, it sounds like we'll still need some level of expert human intervention. And so my next question is, will smarter AM production, enabled by data, fundamentally decrease the need for human expertise? Smart manufacturing may still require some level of manual labor in the form of loading, unloading, or post-processing. But will we be able to replace human expertise? Crystal, will the availability of more and smarter data decrease the role of skilled human intervention?
Well, Christophe, to answer that question, I really think we should nuance the context we're talking about. If you're in a very predictable context where you have a lot of data, I think their machines obviously can play a very important role because they are accurate, they're fast, they're consistently rational. So if you take the example of a self-checkout system in a supermarket, these systems are operating for 80% independently. It's only when there's like a particular situation, like a client who needs help, in those 20%, humans can be supervisors. But that's when you have that data and you know where you're going. If you go to the other side of the spectrum, you're in a very uncertain context with a lot of ambiguity. For example, when you're innovating, well, there obviously, per definition, if you're innovating, there's less certainty. Often there is not data or there is contradicting data. And there you need real core human skills like creativity, imagination, intuition. And those skills are far from being automated by machines. If you think of the fact of organizing space travel, or like our CEO 30 years ago was thinking, what if I revolutionize healthcare with 3D printing? That's something only humans can do. And so there they are the creators. Now, between those two spectrum of being a creator or simply a supervisor, there's a lot of shades of gray. And there's also situations where human and machine will work hand in hand, like in law firms, where all the documentation is being gathered by machines, but the interpretation and preparing the case is still done by the lawyer. So as you can see, depending on the context, human will play different roles in combination with machines.
Yeah.
I think sorry, Crystal.
No,
I
go
think
ahead.
it's a good point, Crystal, that you make there. The spectrum that you mentioned, I would even say take care, because even at the spectrum where you have a lot of data, and I'm talking in particular about additive manufacturing, there is that specificity of an individual company. And I am a firm believer that only with data you will not be able to automate a lot of things, or you can automate crap. The importance here is as well the domain knowledge.
Yeah.
And the domain knowledge is with the people. And if it's possible to give the right tools to those people to convert their domain knowledge into actionable insights with the data that you create and generate, at that moment in time you really get to smart manufacturing.
Mm-hmm.
Okay, so what's the end conclusion?
Well-
Will smarter and more data replace human expertise?
Well, if we really look at the context of additive, I think that what Bart was mentioning, I think that's interesting because indeed, even in the scalable of the operation of additive, and at the later stages of additive, there indeed only data will not suffice. It's already very complicated for a given design, in metal, for example, for a given post-processing technique, for a given orientation, to still optimize and automate that process, that's hard. Can you imagine for all the businesses that are getting started with additive, where they don't even know yet which business application they have to work on, how the ecosystem will thrive, what kind of different type of designs are available. There, let's say, the degrees of freedom and the equation you have to solve is even more complex. So I think depending on which stage you're in additive, the balance between using the expertise and using the data and the machines will really shift. And for the front stages, I think that having a multidisciplinary team of experts looking at all those facets at the same time will really be instrumental for success with additive. Yeah.
Yes, please.
Additive manufacturing is not only smart manufacturing, it's also manufacturing for smart people.
Explain yourself.
Well, I mean, the manufacturing as such will become smart, but as the manufacturing becomes more smart and data-driven and reliable, it opens up opportunities for smart people to really add value, to creatively add something on top of that. So if you just stick to smart manufacturing, there's a high chance that at a certain point in time, you'll just be doing what other guys around the block are also doing. But if you use the smart manufacturing as a basis to then be smart yourself and add that additional human layer, that's when you really become a layer.
You make the difference.
And that's where you make the difference. Same goes for a surgeon. If he just takes the diagnosis that comes from the system and hands that over to his patient, great, probably also accurate. But if he uses that as a basis to then add whatever additional layer he can add based on his personal interpretation, based on his personal experience, based on the empathical relationship that he has with his patient, that's when that surgeon really becomes a smartly enabled surgeon who adds an additional layer of value to his patient. Contradict me if I'm wrong, Peter.
No, that's the reality. That's exactly the reality that we're seeing. I mean, on the one hand, we're seeing more demand for more complex solutions in the market, more high-end solutions that are going to deliver more value towards patients. But those, if they always come with additional work as well for the whatever expert team that's involved, whether that's a surgeon, an interventionist, or an optician, or whoever as an expert clinical user may be involved in there, then it's not going to be sustainable. So what we do need to find a way to do is support them with data-driven technology, so that basically the repetitive work maybe, or the less complex work can be automated, and they can focus on the tasks that require more insight, that require more expertise, where they can deliver more value. I mean, I'm a gardener myself, and if you look at, if I do in my garden, you make the analogy there as well. I don't mow my own lawn anymore. It's a robot that's doing that. It's a very straightforward, simple job that's always exactly the same. Now, if I have to trim my roses, that requires more expertise, more insight on how I want it to look like.
More love.
More love, exactly. And that's where I want to spend my time. And I always believe that that's exactly where physicians want to spend their time as well, is on those tasks rather than on the repetitive work.
And that's really interesting, because in breakthrough innovation, often it comes from making links between the between things that seem unrelatable or understanding latent needs, which means if you would look into our brains, we have many more associations that would never be showing up naturally in a data set. I think that's really what distinguishes. So if I come back to your question, will it replace? No, I think companies need to be happy to invest in both human expertise and in machine intelligence. But even if you have the best humans and the best machines, if they don't have the third ingredient, that is a process to make those two really work together, we won't be successful.
Yeah.
In conclusion, I think we can establish that data leads to smarter and more automated manufacturing, and this reduces the need for human intervention, but it also frees up time for skilled engineers to do what they do best, defining and in fine-tuning unique AM production processes. One of the challenges will be to establish a workable process of how these two, smarter data and skilled engineers, can work together and enhance each other at every stage of the AM journey. And with that, I want to thank my panel for their actionable insights, and I want to thank you for joining us today. Goodbye.
Thank you.
Thank you.